Ladies and gentlemen, this is Miss Humbert here, and today we're going to do Unit 4 Notes 2. So we're going to talk about properties of parallelograms. So again, this is going to have a lot of theorems and so forth that you're going to need to do the homework. So make sure you have everything written down so it's a reference for you while you do the homework. So first and foremost, let's take a look at this. What is a parallelogram? What does that mean? So for a parallelogram, let me select my pen. Both pairs of opposite sides are parallel. That would make sense. We see the word parallelogram in the actual word itself. So these two arrows mean that this line is parallel to that line. Okay, I've got to catch up here. Likewise, because this has 1, this side is parallel to this side. So, as a reference point, in parallelograms, so we kind of draw a parallelogram symbol in front of it, A, B, C, D. The line segment AB is parallel, that's what those two little vertical lines mean, that they're parallel to DC, and likewise AD is parallel to BC. So let's take a look at some properties that apply to parallelograms. If a quadrilateral is a parallelogram, then opposite legs are, and I'm going to write it below so I have enough space, are congruent. Okay, so that means this side is congruent to this side. This side is congruent to this side. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Okay, so it works both ways. If you have opposite sides that are congruent, then it's a parallelogram. If it's a parallelogram, opposite sides have to be congruent. Take a look at the next property. If a quadrilateral is a parallelogram, then opposite angles are also congruent. So notice these two angles are going to be congruent to each other. You can tell by the little arcs. And same here because there's the same amount of arcs. Likewise, it works in opposition. If both pairs of opposite angles excuse me, and the quadrilateral are congruent, then the quadrilateral is a parallelogram. So it works the opposite way as well. If a quadrilateral is a parallelogram, then consecutive angles are supplementary. So those two need to add up to 180. Those two need to add up to 180. Those two and those two. So they are supplementary. So just as a point to ourselves, angle J plus angle K needs to add up to 180. Angle K plus angle L needs to add up to 180. Angle L plus angle M needs to add up to 180. Angle M and angle J need to add up to 180. So all of those sides that go boom, boom, right in an order need to add up to 180. Well, this shouldn't be a surprise to you. This is kind of like using opposite or consecutive interior angles like we did way back in Unit 2. So you could look at it this way, okay? You could look at it as having two parallel lines here and here. Well, that means that your consecutive interior angles need to add up to 180. Likewise, these are alternate interior angles, so they have to be congruent. So that's where these ideas are coming from. It's really taking from that parallel line unit that we did back in Unit 2. So let's take a look at applying some of this. So in number 1, find the values of x and y so the figure is a parallelogram. Well, for it to be a parallelogram, this has to be congruent to this, and this has to be congruent to this. Well, since this has both an x and a y, let's start with the x, the other one. So 6x plus 3 has to be equal to 15 in order for this to be a parallelogram. So we're going to subtract 3 from both sides, and I get that 6x is equal to 12. So I'm going to divide both sides by 6. And when I do that, I get that x is equal to 2. So x is equal to 2. So now I know what x is equal to. I can solve for that 1 with the y. So I know 4x minus 2y needs to be equal to 2. Well, now I know what x is, so I can substitute that in. So I have 4, and now instead of x, I'm going to put 2 minus 2y is equal to 2. Well, 4 times 2 is 8. Minus 2y is equal to 2. So now since that's a positive 8, I need to subtract 8 from both sides to get it over to the other side. So I'm going to subtract 8. So I get a negative 2y is equal to 2 minus 8, which is negative 6. So now to solve for y, I need to divide both sides by a negative 2, and I get that y is equal to 3. So x is equal to 2, and y is equal to 3. So let's take a look at this next one for number 2. It says find the values of x and y so that the figure is a parallelogram. So what I noticed, first of all, those opposite angles of a parallelogram need to be congruent. So y plus 10 needs to equal 2y minus 40. So let's go ahead and solve for y. Well, this is a positive y. So to get that over to the other side, I'm going to subtract y from both sides. And then I get 10 is equal to y minus 40. And now I need to get that minus 40 over to the other side to get what my y is. So I'm going to add 40. So then I get that y is equal to 50. So y is equal to 50. Now I need to get my x. Well, I notice that these two angles are going right in a row. So y plus 10 plus 4x needs to add up to 180. Because remember, angles that go in a row in a parallelogram need to add up to 180. So I know what y is. I know y is 50. So 50 plus 10 plus 4x needs to add up to 180. Well, 50 plus 10 is 60 plus 4x needs to add up to 180. So now I need to figure out how I'm going to get that positive 60 over to the other side. Well, since it's positive, I'm going to go ahead and subtract 60 from both sides. So then I get 4x is equal to 180 minus 60, which is 120. Lastly, I need to divide both sides by 4. 120 divided by 4 is 30. So x is equal to 30 and y is equal to 50. Taking a look at that next property. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So what does that mean? Well, that means that this diagonal is going to be congruent to that diagonal. And this diagonal part is going to be congruent to that diagonal. So basically that makes P the midpoint of both of those lines. So both sides of the diagonal need to be congruent to each other. Likewise, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. It works in the reverse as well. So let's apply this. So for this next one, it wants us to find the values of x and y. Well, again, the diagonals bisect each other. So 4x minus 2, so a negative 4x minus 2 needs to be equal to a negative 3x plus 4. So, whoa, negative, let me write. Whoa, got a little out of control there. Getting too ahead of myself. Okay, so just give me a second here. Sorry about this, guys. Scrub ahead if you need to. All right, so next for this, negative 3x, come on, negative 3x plus 4. So now we need to get our x's on the same side. So I'm going to go ahead here and I'm going to add 3x to both sides. So then I get negative x minus 2 is equal to 4. So the next thing I want to do is get that minus 2 over to the other side. So I'm going to go ahead and add 2 to both sides. So negative x is equal to 4 plus 2, which is 6. Well, I frankly don't want to know what negative x is equal to, so I'm going to divide both sides by a negative 1, and I get that x is equal to a negative 6. It's okay that x is equal to a negative number because if you were to plug x back into those expressions, the answer would come out as positive. So next, let's take a look at this next one. 3y minus 5 needs to equal 2y plus 8 because they bisect each other. So I'm going to subtract 2y from both sides, and then that gives me y minus 5 is equal to 8. Add 5 to both sides, and you get that y is equal to 13. So x is equal to negative 6, and y is equal to 13. So let's go ahead and take a look at this next problem. So find the values of x, y, and z. So let's start by taking a look at z. Well, how am I going to know what to set z equal to? Well, remember, this is parallel to this, and this is a transversal cutting through. So 3z and 33 are actually alternate interior angles, which means they're congruent to each other. So 3z is equal to 33. So I can divide both sides by 3, and I get that z is equal to 11. Okay, taking a look next, let's take a look at x. So we have those sides. Remember that opposite sides need to be congruent. So 5x needs to be equal to 27. 5x is equal to 27. So to solve for x, we're going to divide both sides by 5, and that gives us that x is equal to 5.4 as a decimal. Last but not least, taking a look at y. So we want to figure out y. Well, if it's truly a parallelogram, this diagonal needs to bisect that diagonal. So this needs to be equal to that. So 2y minus 5 is equal to y plus 4. So I'm going to subtract y from both sides, and I get y minus 5 is equal to 4. So then I'm going to go ahead and I'm going to add 5 to both sides. And when I do that, I'm left with y is equal to 9. So y is equal to 9. Let's go ahead and take a look at some of those final properties here. So if one pair of congruent sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So if we know that this side is parallel to this side and they have the same length, we're talking about the same sides, then we can say that it's a parallelogram. So let's take a look and see if some of these are parallelograms. Well, what I notice about number 5 is that this side is congruent to this side, and this side is congruent to this side. Well, remember, to be a parallelogram, our opposite sides have to be congruent. So let's see. That means yes, it can be because our opposite sides are congruent. Well, we know that this side is equal and this side is equal. We also know that this angle and this angle are 85. Well, we don't have a theorem that tells us anything about angles and sides being related. So there's not enough info for this one to conclude if it's a parallelogram. So for this side, we know that this is parallel and this is parallel, and also these sides are the same length. So by that theorem 6.12 that we just looked at, yes, this is a parallelogram. For number 8, all we know is that two sides are the same length. That doesn't tell us anything, so there's not enough info on that one to identify if it is a parallelogram. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.